What you said, guys? You want more hypotheses testing? Oh, here we go. I'm going to answer your dreams. They're going to come true. So, number 32 states, the mean annual tuition and fees for a sample of 11 private colleges was $26,500 with a standard deviation of $6,000. A dot plot, which we don't see, shows that it is reasonable to assume that the population is approximately normal. You wish to test whether the mean tuition and fees for a private college is different from $31,000. 1. State your null and alternative hypothesis. 2. Compute your test statistic and state the number of degrees of freedom. 3. State your conclusion regarding the null hypothesis. Use the alpha level of 0.05 level of significance. Alright, I will answer all these questions, but because the final is on Connect Math, I'm going to do the Connect Math version first, then I'll answer the question second. Or probably I'll answer it when it needs to be answered. Alright, now, number 1. We want to write our hypotheses, our null and alternative. The null states that there is no difference between the parameter, which is going to be mu, and a specified value. In this case, the specified population value is going to be 31,000. Don't use 26,500 because that value right here comes from a sample of 11 private colleges. That's not a parameter, that is a statistic. So let's write that here, 31,000. We want to write our alternative, which means mu will either be greater than, less than, or different from 31,000. The question says, you wish to test to see whether the mean tuition and fees for a private college is different from $31,000. When it says different, difference can mean greater than 31 grand, less than 31 grand. It just can't be $31,000. Therefore, that is going to be a two-tailed test. Mu does not equal to 31,000. Not the claim. This is the claim. And this is a two-tailed test. Given to us by the symbol of not equals to. All right. Number 2, you want to find your critical values. You got to know the test you're running, your direction, which you already know. It is two-tailed. The alpha level, which is going to be 0.05. And if it's a test that requires degrees of freedom, you must find your degrees of freedom. In this case, this will be a t-test, better known as a one-sample t-test. Why is it a t-test? Let's read the first sentence. The mean annual tuition and fees for a sample of 11 private colleges was $26,500 with a standard deviation of $6,000. This standard deviation is coming from the sample of 11 colleges. Therefore, we do not know our population standard deviation. Rather, we have a sample standard deviation. And when you have a sample standard deviation, you are using a t-test. Which means to find the critical value, because this is a t-test, you must also find the degrees of freedom. And the degrees of freedom is your sample size minus 1. We have a sample of 11 colleges. So my degrees of freedom is going to be 11 minus 1. And 11 minus 1 is going to be 10. So now to find the critical values, and it's going to be two critical values because this is a two-tailed test, You're going to go to your T distribution. Why is it always so blurry when I go to it? Makes me sad. This is a two-tailed test. So you're going to go to two-tailed alpha 0.05, right? Degrees of freedom is 10. So let's go down to 10. Degrees of freedom is 10. Highlight that up. Two-tailed 0.05. There goes the critical values. The critical values is going to be negative and positive 2.228. Once again, what is a two-tailed test? You need both a negative and a positive value. So negative 2.228, positive 2.228. Step 3, compute your test statistic or your test value using the t-test formula. T equals to the sample mean minus the population mean divided by the sample standard deviation, sometimes called the estimated standard deviation, which is divided by the square root of the sample size. The sample mean in this case from 11 colleges was $26,500. My population of mu is stated in my hypothesis, which is 31,000. My sample standard deviation was $6,000, and my sample size was 11. Look at my memory. I'm doing great for myself. Let's zoom out. So T is equal to, and you're going to round the final answer to 3 numbers after the decimal, 26,500 minus 31,000 divided by $6,000, which is divided by the square root of 11. Let's plug that bad boy into the calculator. Use parentheses. So 26,500. My apologies. Minus 31,000. Close that up. Divided by, open parentheses, $6,000. Excuse my lisp a little bit. Divided by the square root of 11. Close that bad boy up. Take 3 numbers after the decimal. My test statistic is going to be negative 2.487. That 4 right there keeps that 7 the way it is. Number 4. Make our decision. We're going to draw our standard normal curve. We're going to place our critical values on the curve. Two-tailed, so 2 critical values. Negative 2.228, positive 2.228. If my test statistic falls within my highlighted area, which is known as the critical region, we're going to reject the null. If it falls in the non-highlighted area, which is the non-critical region, we do not reject the null. Our test statistic is negative 2.487. That will fall on the left side, and it will also fall within the critical region. Because it falls within the critical region, we will reject the null hypothesis. That is the answer to number 4 if we're doing the Connect Math version. Because we reject the null hypothesis, we're going to restate the alternative. Number 5, which means there is enough or sufficient evidence to conclude the average tuition for private colleges is different from $31,000. All right. So this is how we do our one sample t-test, which is a two-tailed test in this case, using the traditional method. But once again, we had different guidelines in the review sheet, so we're going to answer the questions. Number 1, state our null and alternative hypothesis. Well, this number 1 right here will be number 1 right here. That is the answer. Number 2 says compute your value of your test statistic, which we did in step 3. So that's going to be t equals to negative 2.487. And the number for the degrees of freedom, our degrees of freedom is going to be 10. It says state a conclusion regarding the null hypothesis using the alpha level of 0.05 test level of significance. That is step number 5, which we did. So we answered all the questions for number 32. And what that means is I can end the video. All right, guys. I'll see you soon.